Our group was asked to design a safety storage facility that uses the MQTT access system to be able to open the electronic lock of the storage facility. The focus of this video will be largely on the process flow chain, starting from the client requirements. Following the process, it will end with the fully assembled 3D additive manufactured prototype. From the house of qualities, the best characteristics for a concept were identified, largely based on the client's requirements being changed into engineering characteristics, as well as being able to compare with competing products on the market. From the engineering characteristics and the house of qualities, we start with the design process. Starting off with step one, each group member will create a rough sketched ideas and present it to the other group members. From this session, the best concept could be chosen and thus can be used as the final design. From the final chosen concept, each part needs to be identified, as well as its quantities. The first part will be the door side panel. That will be the only part that's going to be moving and will be housing the access system. Next will be the elbow joint. It would be used on the inside of the safety storage facility to lock in the parts. Next is the hinge component 1, hinge component 2, and hinge component 3. These will largely be used in the locking system for the front door, as well as the next part, the lock elbow, and the locking component. Next will be the eye connection parts, where multiple of them will be printed to make the inside stable as well as the outside, but not being accessible from the outside. And finally, the side panels. After they've created the part files, it needs to be assembled in CAD to check if it is correct. And then finally, it needs to be converted to STL files. That is the only files that can be used to 3D print. Now we are ready for our additive manufacturing processes. It starts off by firstly consulting all the experts for the additive manufacturing processes. During this time, it is ideal to check if all the parts fit, and it's ideal to check if all are in the right quantities and can be printed by the 3D printer. Now from this next step, we will have to identify the parts that are problematic, i.e. those that could not fit from either being too large or too small, etc. Now the side panels were identified as being way too large for the actual 3D printer, so they needed to be redesigned. Instead of recreating a new concept, we believed that our concept was ideal. So what we did is just for the prototype, we scaled it down to 67% of the original part. After that, all the other parts were scaled down 6 times so it could all fit into one printing. Now for the final part, it will be ending off with printing it and assembling everything. Assembling it needs the requirements of shaving down sides, the excess, and then putting all parts in. And thus we have the final prototype for additive manufacturing project.